Air-cooled chillers are one of the most widely used cooling systems in commercial and industrial applications. They are designed to remove heat from a building, process, or equipment by using ambient air as the heat rejection medium. Unlike systems that rely on cooling towers, air-cooled chillers transfer unwanted heat directly into the surrounding air. This makes them highly practical, efficient, and suitable for locations where water availability is limited. In this video, we will explore the principle of air-cooled chillers, how they work, their main types, applications, and key benefits. An air-cooled chiller is a refrigeration system that removes heat from water or another fluid and transfers that heat into the outside air. The chilled water produced is then circulated through air handling units, fan coil units, or industrial processes to provide cooling. It is important to understand that a chiller does not generate cold. Instead, it removes heat from a space and transfers it elsewhere. By continuously removing thermal energy, it lowers the temperature of the conditioned area or equipment. Air-cooled chillers are commonly used in HVAC systems, industrial processes, data centers, district cooling systems, pharmaceutical plants, and manufacturing facilities. The working principle of an air-cooled chiller is based on the vapor compression refrigeration cycle. This cycle includes four main processes: compression, condensation, expansion, and evaporation. The system uses a refrigerant that changes state between liquid and vapor. By manipulating pressure and temperature, the refrigerant absorbs heat from the chilled water circuit and rejects it into the surrounding air. The cycle continuously repeats, ensuring constant cooling. An air-cooled chiller has five main components. The compressor, which may be screw, scroll, or reciprocating type, acts as the driving force of the refrigerant and increases its pressure and temperature. The condenser consists of horizontal tubes containing hot refrigerant. These tubes are surrounded by thin metal fins that help transfer heat into the air. Condenser fans draw ambient air across the condenser coils and discharge the heated air into the atmosphere. The expansion valve reduces the refrigerant pressure and controls the flow into the evaporator. The evaporator is where chilled water is produced. Heat from the return water is absorbed by the refrigerant and transferred to the condenser. The cycle begins at the compressor. The refrigerant leaves the compressor as a high-pressure, high-temperature superheated vapor and enters the condenser. Inside the condenser, fans force ambient air across the condenser coils. As the refrigerant releases its thermal energy to the air, it begins to condense into a liquid. By the time it leaves the condenser, it becomes a high-pressure, medium-temperature saturated liquid. Next, the refrigerant flows into the expansion valve. The expansion valve meters the flow and creates a sudden pressure drop. As the refrigerant passes through the small orifice, it expands and becomes a low-pressure liquid-vapor mixture. This process significantly reduces its temperature. The cold refrigerant then enters the evaporator. In the evaporator, it flows through tubes that are surrounded by warm return chilled water. The refrigerant absorbs heat from the water, causing the refrigerant to evaporate into a low-pressure vapor. The chilled water leaves the evaporator at approximately 6 degrees Celsius, 42.8 degrees Fahrenheit, and is circulated back to the building or process for cooling. The refrigerant then returns to the compressor, and the cycle repeats continuously. Air-cooled chillers are classified mainly by the type of compressor they use. Air-cooled scroll chillers use scroll compressors and are commonly applied in small to medium capacity projects. They are simple in design and suitable for residential buildings and light commercial use. Air-cooled screw chillers use screw compressors and are designed for higher cooling loads. They are more suitable for medium to large commercial buildings. Magnetic bearing chiller turbocompressors represent an advanced technology. These compressors operate without oil, using magnetic bearings. Eliminating oil improves heat transfer efficiency and reduces maintenance. These chillers are widely used in large-scale applications, such as district cooling and high-efficiency industrial systems. They also provide excellent performance at partial loads and achieve significant energy savings. Water-cooled chillers use cooling towers to reject heat instead of ambient air. They generally offer higher efficiency because water has better heat transfer properties than air. However, water-cooled systems require significant water consumption and additional infrastructure such as cooling towers and pumps. This increases installation complexity and operational costs. Air-cooled chillers, on the other hand, require no cooling tower, consume no water for heat rejection, and are easier to install. They are often preferred where water conservation is important. Applications of air-cooled chillers. Air-cooled chillers are used in a wide range of industries. They are commonly installed in commercial buildings such as office towers, hospitals, shopping malls, and hotels. They are also widely used in data centers, where precise temperature control is essential. Industrial processes in plastics manufacturing, food processing, pharmaceuticals, and chemical plants rely heavily on air-cooled chillers. District cooling projects and manufacturing facilities also benefit from their flexible installation and scalability. Benefits of air-cooled chillers. Air-cooled chillers provide strong energy efficiency by eliminating the need for cooling towers and water pumps. This reduces overall operating costs. They offer simplified installation because they are self-contained units. Since they do not require a water supply system, installation is faster and less expensive. Their compact design allows rooftop or outdoor installation, saving valuable indoor space. They are flexible and scalable, allowing capacity expansion as cooling demand increases. Environmentally, air-cooled chillers reduce water consumption, and modern refrigerants have lower global warming potential. Improving sustainability. Maintenance requirements are generally lower compared to water-cooled systems, reducing downtime and service costs. Air-cooled chillers are reliable, efficient, and versatile cooling systems used in a wide range of commercial and industrial applications. By using ambient air to reject heat, they eliminate the need for water-based cooling infrastructure. Understanding their working principle, components, and types helps engineers and technicians select the most suitable system for each project. With advancements in compressor technology, especially magnetic bearing systems, air-cooled chillers continue to improve in efficiency, sustainability, and performance.